Everywhere you look, people are asking the same question. Are we actually on the edge of building artificial general intelligence? Or is it just hype? In this video, I'm cutting through the noise. We'll break down what AGI really means, how close current AI systems actually are, what's still missing, and the signs you should be watching to know if we're truly approaching it. Let's start with the basics. Now, what exactly is AGI? The plain definition in human terms is that artificial general intelligence is an AI that can understand, learn, and reliably perform most cognitive tasks that a human can across many domains without being retrained for each new task. Think broad competence plus. Here's how a couple of sources frame it. OpenAI says AGI is a highly autonomous system that outperforms humans at most economically valuable work. Shane Legg, co-founder of DeepMind, said that systems can achieve human-level performance on essentially any intellectual task, often called human-level AI, is AGI. Russell and Norvig from AMA say that AGI is machines with human-level generality, not narrow specialists. And the EU uses GPAI, or general purpose AI, to mean models usable across many applications. That's not the same as AGI. GPAI is broad applicability, while AGI is human-level generality and reliability. Now, there's a lot of confusion around what AGI is, so we're going to cut out some common misconceptions. AGI is not superintelligence that is beyond human across the board. It is not consciousness or sentience. That is a separate unsolved question. It's not just a big LLM that chats well or passes a few benchmarks, and it's not the Turing test alone either. It is broader, sustained competence in the open world. Now, most definitions of AGI apply these 5 core properties. Cross-domain generalization and transfer. That means it learns one thing and leverages it elsewhere. On-the-fly learning, it adapts from small demos, minimal hand-holding, things like that. Long-horizon reasoning and planning. It works toward goals over many steps. Tool use and orchestration, code, browse, call APIs, and coordinate them. And robustness and reliability. Consistent, verifiable outputs under real-world messiness. If we put all that together, we arrive at this working definition for this video. AGI is an AI system that can autonomously learn and perform the majority of economically and cognitively valuable tasks at roughly human level or better across diverse domains with reliable reasoning, long horizon planning, and safe tool use without per-task retraining. Now, why does this matter? Everything else in the video, benchmarks, timelines, and how close are we, hinges on this bar. We're measuring breadth and reliability, not just flashy demos. Now, here's the problem. Depending on who you ask, AGI is already here. It's a decade away, or it's impossible. Why such different answers? Because everyone is using a different definition. If your bar is chatbots that can write essays and code, then you might say we've already crossed into AGI. But if your bar is an AI that can reliably plan, reason, and execute long-term goals across many domains, then we're still miles away. That's where the benchmarks come in. Today, researchers measure progress with academic tests like MMLU or Big Bench, which check knowledge across thousands of subjects. Real-world tasks like coding, reasoning, or summarizing research. Agent evaluations, where the AI has to actually plan and finish multi-step projects. Robustness and safety tests, which see how models hold up under pressure, edge cases, or adversarial prompts. Each of these points to a different picture of closeness. For this video, I'm using our working definition. Right now, models look impressively general on paper, but the independent evaluations paint a mixed picture. The Stanford AI Index of 2024 reports big jumps on knowledge tests like MMLU and coding benchmarks, yet highlights persistent issues with reliability, truthfulness, and adversarial robustness. On real software tasks, academic benchmarks like the SWE bench from Princeton show agents still struggle to solve and ship end-to-end bug fixes in real repos without heavy scaffolding. Good autocomplete, uneven autonomy. Agent Bench from Tsinghua and ARC evals from the Alignment Research Center find multi-step planning and tool use help on structured tasks, but performance degrades with longer horizons and messier environments. Government and standards bodies also at the reliability gap. NIST and the UK AI Safety Institute emphasize brittleness under distribution shift, prompt injection, and safety stress tests. Independent papers like LLMs are not zero-shot planners, and follow-ups show step-by-step reasoning can look coherent while still failing at causal and temporal reasoning and multi-stage execution. Multimodal models are strong at perception and basic reasoning, but the combo of robust reasoning, week-long planning, and dependable tool orchestration isn't there yet. In short, today's systems demonstrate broad competence and useful tool use. AGI-level reliability and autonomy across domains remain unproven on independent, real-world style applications. Now, if we're not at AGI yet, you might have the question, what is still missing? The answer is a couple of things. First, reliable reasoning and verification. LLMs can sound right while failing basic math, logic, and causal inference. Even chain of thought isn't a guarantee. Verifier models help, but don't close the gap. See independent findings. Second, long horizon agency. Performance drops as tasks require multi-day planning, tool switching, and recovery from errors. Academic and neutral evals like Agent Bench and SWE Bench show uneven end-to-end autonomy on real repos. Local edits, weak at full task completion without scaffolding. Third, grounding in real-world models. Current systems lack durable, testable models of how the world works. They conflate pattern match with causality and struggle under distribution shift. Fourth, memory and continual learning. Models don't reliably update from new experience without retraining and risk catastrophic forgetting. External memory helps, but remains brittle. Classic continual learning literature and recent empirical notes in the AI Index highlight this as open. Fifth, robustness and adversarial resilience. Prompt injection, jailbreaking, and data poisoning remain effective, especially in tool use. Sixth, tool orchestration and reliability. Calling code, browsers, and APIs boost capability, but orchestration fails with partial outputs, API errors, or ambiguous specs. Independent agent evals show cascading failure without strong verifiers and tight budgets. And seventh, value alignment at scale. Helpful, harmless, honest behavior erodes under distribution shift and adversarial pressure. Constitutional and oversight methods help but aren't guarantees. Government and standards bodies like NIST and the UK AI evaluation briefs emphasize the need for pre-deployment testing, monitoring, and incident response. Independent and government evaluations agree. We've nailed breadth, but not dependability. Until models demonstrate verified reasoning, week-long planning, safe tool use, and resilience under shift and adversary, AGI-level reliability isn't met. When it comes to AGI timelines, The honest answer is uncertainty, and independent surveys back that up. The AI Impacts 2022 Expert Survey found guesses spread from a few years to several decades. More recent policy briefings from GovAI and the OECD highlight that much depends on bottlenecks in compute, data, and reliability. Here's a calibrated way to think about it. Short fuse is 1 to 3 years. If scaling laws keep holding and verifiers and tool use close the biggest gaps, we could see proto-AGI systems that meet many working definitions of AGI in constrained settings. They look broad and capable, but still need human oversight. Our medium horizon is 3 to 7 years. If breakthroughs in reasoning, memory, and world models emerge, autonomy across most knowledge work could stabilize. This is where reliable AGI starts to look plausible. Agents that can execute projects with less babysitting. And our longer horizon is 7 to 15 or more years. If bottlenecks bite harder, like data limits, compute costs, or the robustness gap, progress may stall into an S-curve. In that case, we'd see steady but incremental improvements, with AGI arriving only after new architectures or fundamental advances. Why do experts disagree on this? Well, some extrapolate from rapid capability jumps we've already seen, and others emphasize structural limits like energy, safety, and governance. Independent reviews consistently warn against both doom and hype. Progress is real, but the timelines are wide. Now, what does this mean for you? Well, different things based on who you are. Now, if you're a builder, the smart bet right now isn't chasing full AGI. It is investing in agentic workflows, strong retrieval systems, and verifiers that can fact-check and catch errors. Build monitoring and rollback mechanisms into everything, because reliability gaps are where projects fail. For teams and businesses, don't assume today's models will just work out of the box for your hardest problems. Create human-in-the-loop guardrails and evaluate agents on your real-world tasks, not just flashy demos. Independent benchmarks are useful, but nothing beats stress testing in your own environment. For everyone else, tune out the hype cycles. Watch for signals like, can models consistently reason step by step? Finish multi-step jobs with tools, self-correct errors, and learn from a few new examples without retraining. Those are far better indicators of closeness than some viral demo. So, are we close to AGI? The answer is, it depends on where you set the bar. If your definition is broad competence with tools and knowledge, then yes, AGI feels pretty close. But if your bar is autonomy, trustworthiness, and week-long problem solving without human handholding, then we're still further away. Here's the checklist to watch in the next 12 months. 1. Consistent reasoning across domains. 2. Agents completing complex projects end to end. 3. Reliable self-corrections with citations. 4. Durable memory and learning from small demos. And 5. Safety evaluations verified by independent groups. If those boxes start getting ticked, then we're not just close, we are crossing the line. So that's my take on how close we are to AGI. I hope you all enjoyed. Be sure to leave a like and share your thoughts with the class. And before you subscribe, make sure you know what you're doing, because it ain't easy being at the top. I'll see you guys next time.
And hear the echo call.